Welcome to lecture on conditional probability. In this lecture we talk about definition of conditional probability and different examples. In order to understand conditional probability, first of all let us discuss few examples in which we will come to know how probability of an event influences with respect to occurrence of other events. My first example is, observe there are three circles in which the bigger circle represents the number of people in a particular region and the circle T represents the number of international traveler in that region. C represents number of COVID positive tested people in that particular region. In this scenario, my first question is, first understand the questions. What is the probability that a person tested COVID positive? I am repeating, what is the probability that a person tested COVID positive? Second question, what is the probability that a person tested COVID positive given that the person is international traveler? So in second question there is another event, that is person is international traveler. How the person tested COVID positive is influenced by the event that the person is international traveler. This is a first example. The second example what I am giving you, diesel and petrol consumption. What is the probability that petrol consumption on an average in a month greater than a particular number X in India? Second question is, what is the probability that a petrol consumption on an average in a month greater than X in the year 2020, right? So there are other factors which influences the petrol consumption as we know at present scenario. Okay, so in this case let me elaborate the first example with certain statistics. Number of people is represented by some P, and number of people who tested who are international travelers, number of international travelers in this particular region. You can see from the Venn diagram it is X plus Y, and number of persons who tested COVID positive in this region Y plus Z, right? All the remaining people W, all the remaining people are W. Okay, so my first question is, what is the probability that a person tested COVID positive in this scenario? You can easily understand from this Venn diagram there are Y plus Z persons in this region out of the total number of people in this region. So I can say Y plus Z with equal probabilities each person, that all prerequisites are considered, Y plus Z by number of people in this region. That makes sense. Second point is probability that a person tested COVID positive given that, this is the key word in this conditional probability, given that means one more event is happened, given that he is international traveler, she or he is international traveler. So in this scenario what you can say, A person tested COVID positive, at the same time he or she is international traveler. So how many such people? COVID positive and international traveler, there are Y people. If you understand more clearly here, is international traveler. That means indirectly we are finding the probability of a person tested COVID positive from the international traveler. From the international traveler, because that event is already happened. This is the crux of this conditional probability. Try to understand. Is international traveler. So number of international travelers in this example x plus y. That is y by x plus y. The probability that, the third example in this, probability that a person tested COVID positive given that she or he is not an international traveler. Not an international traveler. So not an international traveler. So in this case, a COVID positive and a non-international traveler. COVID positive and non-international traveler in this example, Z by total number of non-international traveler. So you need to write the total number of non-international traveler. Okay, so that you can get W in this example, Z by W. Okay, so from this example, if we try to generalize, we can observe that A comma B are two events, A, B are two events in a random experiment with sample space S, that their probabilities are non-zero. Their probabilities are non-zero. Okay. So let me write an event here, new event, happening of an event A, given that B happened, it is represented by A over B. Happening of event A, given that B happened. Similarly, happening of an event B, given that A happened. So then it would be represented by B by A. Okay. So while we are generalizing, it's a conditional probability, we can consider two circles here, A and B. This is A and this is B. This is common area. I guess you could say in this case, P of A by B, probability of happening of A given that B happened, is equal to, we are calculating the probability of A under the condition B is happened. Then that would be probability of A intersection B over B happened. So B happened. So we are in the region of B. Right? So then sample space would be P of B. I hope it makes a clear sense. P of B by A. Then P of B intersection A over A is happened. So we are in the region A. So then P of A. Of course, P of B, P of A are not equal to 0. I have taken already probabilities with non-zero. right? So by this we can write a couple of points for P of A intersection B. P of A intersection B. By this couple of points for P of A intersection B. So P of A intersection B is, suppose P of A is happened, then happening of B after happening of A, which is equal to, the other way you can write, if B is happened, then calculate the probability of happening of A given that B is happened. So by conditional probability, again you can write P of A by B is equal to P of B times P of happening of A given that B happened, right? So P of A intersection B can be expressed in this way. If it happens for three events A, B, C having the previous conditions, then P of A intersection B intersection C would be equal to P of A, P of B by A, next P of happening of C after happening of A and B both are happened, so A intersection B. Happening of probability of happening of A, probability of happening of B given that A happened, probability of happening of C given that A and B both happened, right? So next, coming to n events, we can generalize this result as A1 intersection, A2 intersection and so on, AN, which is equal to P of A1, happening of A2 after happening of A1. Now happening of A3 after happening of A1 and A2 and so on, the last one happening of AN after happening of A1, A2 and so on, AN minus 1. So this is in general what you can write. So now let us discuss finally one example on this conditional probability. In this example, a box contains 5 black, 3 red balls. A ball is taken out of the bag and is not returned to it. Now the first question is, what is the probability of drawing a red ball in the first draw if the ball in the first draw is red? There is a correction here, the second draw. This is the second draw. If the ball in the first draw is red, what is the probability of drawing a red ball in the first draw and a black ball in the second draw? What is the probability of drawing a red ball in the second draw? So let us consider all the three events. So there are the three important factors here. The first one is, I will name it as A. A is the event of drawing red ball. A is an event of drawing red ball in the first draw. Red ball in the first draw. B is an event of drawing red ball in the second draw. C is an event of drawing black ball in the second draw. So these are the useful events in order to answer this question. When you come to the first question, again let us read the condition. Probability of drawing a red ball in the second draw. If the ball in the first draw is red, so that means already first draw having red. So first ball is already drawn, which is red ball. So that is already happened. So then what you can say, you can understand it is a conditional probability. You need second draw red ball. Second draw red ball event is represented by B. So what it is happened already? The first ball drawn is red. So B over A. So P of B over A. So what is a P of B over A? First ball is already red. So now we are with the 2 red balls. And total 8 balls. Already 1 red ball is drawn first draw. So now the remaining 7. 2 by 7. So coming to the second point. What is the probability of drawing a red ball in the first draw? Red ball in the first draw. And the black ball in the second draw. P of A intersection B. P of A intersection B. You need to take the red ball in the first draw and red ball in the second draw. Right? So P of A intersection B. What is that? The first ball red 3 by 8. 3 by 8. The second ball is black. So this is A intersection C. Second ball is black. So what is the probability of taking a black ball in the second draw? So 5 balls, 5 black balls. So total 7. So this is 15 over 56. Okay. The second ball drawn is black. So P of A intersection C. Coming to the third one. What is the probability of drawing a red ball in the second draw? Red ball in the second draw. So P of B. So what do you say? Second ball is a red ball. When it is a second ball red ball, so what is the first ball? What is the first ball? The first ball can be red. First ball can be red. Second ball red. First ball can be red. So that is P of A. Second ball red. So P of B by A. Suppose the first ball is black. So first ball is black. First ball is black. And P of second ball is red. Second ball is red. So second ball red is P of B by black. So that's the way how do we write in conditional form. So in this case P of A. What is P of A? P of A is the first ball red 3 by 8. Second ball is also red. Second ball is also red. Second ball is also red. So second ball is red means 2 by 7. Plus first ball black 5 by 8. Second ball red. Second ball red. So now we have 3 balls 3 by 7. So this is the probability of drawing a red ball in the second draw. So carefully we need to understand how or which event is influencing the given events. Okay. I hope you understood the conditional probability basic points. So thank you.